Hello everyone, welcome back again. This is actually the other part or like the other point that we are discussing in the second part of this session from chapter 6. So this is actually a totally kind of different a point. That's why actually I was wrapping the previous part as in one recording. So now we are talking about the two types of variables here. And why we are talking about variables here in this point, and we have already discussed or like part of these variables or like variables in chapter 2, if you remember in this course, is that actually because this classification that you are seeing here or as you are reading, that we seems that we have two types of variable, local and global variables. They're actually tightly related to functions, especially when we talk or like when we are introducing the global variables. Okay, so a variable, so a local variable here, this is the typical variable that you have been studied before and you have been working with a lot. So whatever variables that you were declaring before, before this before in the previous in your previous experience, for example, int name and number equal to 6, double rate, okay, string name equal to Hamlet, okay. So char, I'm typing string wrongly, okay, char code, for example, equal to a. That should be so all of these are actually called okay, so that's why I'm just writing them in a very abstract way. Of course they have to be included in a function, and we have been practicing this. Now before this chapter we have we were only know that we need to have a main function, and within the main function we have all of these kind of we need to have all of these variables being amended to to that function, and then happen to be between these two brackets. So all of these are actually called local variables. Okay, so all of these we call them local variables. Why we call them local variables? It is because within a program they are only being their scope, it's only accessible to a part of the program. Okay, although we have the main function, and the main function happen to be the main the main part of the program that can be processed, but this doesn't mean that the main function is the entire program. As we have learned before in this and in this chapter in particular, we may have another functions, for example sum, okay, and where you need to write some code here, and also you can actually have another kind of function, for example void, for example show result. Okay, so this indicate actually that you may have actually other variables here, x equal to 7 here. Okay, so this means that this variable, whatever, for example num here, the scope of this variable is from the point that we initialize that variable until the end of the function, or until the end of its block. So this block, the block of this variable here, it is only the nearest closing bracket here. So if this variable happen to be within the if statement, for example, if let me just move this if statement in here. So if number is less than or less than 5, then of course this should be okay. So that actually should be the the variable. So here this is another type of this is another kind of variable that it's called also a local variable here. Why? But this local variable, it has more limited space or more limited scope than the other variables, for example number and rate. Okay, so so meaning that we cannot use actually name here, we cannot use the name here outside this this code. Why? It's because the nearest the block of this variable that can define its scope, it's only between these two brackets here. So the the nearest curly bracket to the variable here, it defines the limit of its scope. Okay, so all of these that we have talking about, we call them as a local variable. Same goes to whatever variables have been defined in the other functions. All right. So for example, int h equal to 8. Okay, so all of these we talk them as a local variable. Even the variables that come from parameters, for example, you are reading r. So imagine that this, that this function is accepting or is receiving a value that is being stored in a parameter variable. So this is also is being categorized as a local variable. Okay, so however, it's actually listed in the parameter. So, okay, so we have understand now what is actually a local variable, and this is the one that you have already learned before. Okay, so let's just come back into the slides and read some kind of conceptual explanations about that. All right, so it defines within the function block. It's accessible only within the function block. So as you mentioned here, so it's only within the function block accessible. We cannot actually use h here. We cannot say that here and another statement that h, for example, equal to 7, for example. Okay, or h equal to let's just say here h equal to s minus s6, for example. Okay, so we cannot say that. This is wrong. Why? It's because we need to handle like this function, and this function, it will assume that this variable doesn't exist. Okay, so it needs to be either defined from the beginning, or it has not to be used like this way. All right, so other functions and blocks can define variables with the same name. Okay, but this is actually not advised to do. Okay, so what I want to say, exactly the same example here. Okay, so I can define this variable here, typically the same name as another variable. Why? It is because it seems that there is actually the variable here, it only exists, when the compiler reaches the end of the function, compiling the executing the code. After this variable will be destroyed. So meaning that, what I mean by destroying, it means that it will be removed. So it doesn't matter if I have in another function the same variable of the variable of the same name, because they will be isolated from each other. So this variable will not be existed after the execution of this function. After I execute this function, meaning that after I call this function in any place, can be in the main or any other function. So whatever, after the execution have been done and the compiler went out of the function going to the main, so whatever variables here, they will be destroyed. So there will be no, it actually doesn't, it will be fine to say somehow to define a variable with the same name. But again, I'm saying I'm not really advising you, especially like a level of beginning programming, and programmers who are actually trying, beginning and learning the programming. You're not really advised to do so, because this will confuse you a lot within the way you are writing your code. All right, so but this is possible, meaning that it doesn't actually show any syntax error. When a function is called, the local variable or the function are not accessible within the function of, the function called from. So meaning that whenever I call this variable, whenever I call this function, of course I cannot access the variable from there. Imagine that I'm having like the main function here, so int main between two brackets. Okay, so return 0. Imagine that I want to I want to call show result. So whenever I'm calling this doesn't mean that I can actually use the variable name, whatever variable name in here. Okay, it doesn't mean that I can say that x. I cannot say that int, for example, number equal, or like number value to say equal to s, for example. Maybe let me just do some expressions, s plus 7 here. This is totally wrong. Why? It's because s here, however, some of you, show results here. Some of you may think that, okay, so since you are calling this function, meaning that you have, you have a linkage between this function and this function, so meaning that you can access the variables from here, which is wrong actually. So again, I'm saying for the same reason, is that functions are something like variables that has been defined between different functions. They are isolated from each other, meaning that you cannot actually use these variables from one function to another. And this is actually the limitation, to say, of the local variables, is that we cannot use them between, like over the different functions. All right, so we were here. All right, so a local variable only exists while the function is while its defining function is executing. So this variable will not be existed as long as even if we have written it like this. And so, okay, let's just come back here. For example, let's just come back here. We have these two functions. We have called only one function, lifting the other function not called yet. Okay, so this means that whatever code inside this function, whatever variables here inside this function, they will be assumed as not existed. Why? It's because they are, that function has not been linked, or it has not been called yet, so that the compiler, it will not go over it. And you need to notice this. It doesn't matter whether or not you are typing this function in the compiler. This doesn't mean that, like whenever you type this function in the compiler without linking it or without calling it, so no matter whether you type it or not, it will not change anything in the program. Okay, because it's not being called, meaning that it's not going to be executed. So meaning that the variables here, whatever variables containing in the function, they will not be actually existed. They will assume to be nothing, or like not there. That's why we can use actually the same variable names again. So local variables also will be destroyed after the termination. So when the function is reading this and finishing here and returning to the main function, for example, so these variables will be destroyed. So meaning that if I have another value here, if I want to say like int s equal to 5, I can do so. This is very, very easy, meaning that because actually the variable names have been, like the body of the function will be terminated, will be destroyed, to say. All right, so now to say that, now it seems that we have a limitation. When we talk about functions, we cannot actually use the local variables over the different functions. So I cannot use, like, say 7, I want to read number 7, or like the value of s here. I cannot read it from here. Okay, of course, unless I use the return, and this is one way to read values between functions, to say, okay. But if I want a variable that has a global, I want a variable that has its value to be shared over different functions, okay, and it can be shown over different functions. This is why, this is the reason why we are using global variables. So a variable that defines outside all the function, and it's accessible from all the functions, and its scope here, it is actually from the point of definition until the end of the program. It's not until the end of the function. Okay, meaning that the entire program will be the scope of that global function, of that global code variable. So this is the purpose, to easily share a large amount of data between functions in order to make it kind of easy. But you need to be careful when you are defining global variable. This doesn't mean that local variables are nothing and okay, let's just get out of them. Why am I using a variable that like a piece of memory? Because finally the variable definition is a piece of memory. Okay, why am I using a piece of memory that it's actually very limited, doesn't help me a lot whenever I'm dealing with function? And I'm advising you not really to think of it like this way, because local variables, they are really saving a lot of memory locations. Because defining a global variable, it is very difficult for the memory to handle them, especially when you have too much of them. Okay, let's say that now you're actually learning, and this is your experimentation level. So you may be dealing with only 1 or 2 maximum, or maybe 3 global variables. But for your best practice later on, when you talk about like when you're implementing real world scenarios, global variables are not really advisable unless you want to use them for a specific purpose. That's why, and this is the the meaning of this statement. Uses sparingly, is being used sparingly because they are consuming memory. All right, so this is another point to differentiate between local and global variable, is that the local variables here, if you notice that we need to assign them. So meaning that, imagine that if I just type here int s and as a local variable, and then I just keep quiet. So here this means that s has been defined, but it's not initialized. So if I want to see out s here, this will give me an error. because here it says that the error it will indicate that the compiler error will indicate that you don't have any value that has been stored in S. Okay, but if you're defining a global variable, okay, and now I'm going to show you how to define a global variable. Let's just go to the compiler in this occasion and say, okay, so the global variable most likely is being defined wherever you are identifying the prototype. Okay, right after, doesn't matter right after or before. Okay, but actually most importantly it's before you are starting any kind of I mean like outside all the functions, even outside the main function, not even inside the main. So it should be outside the main function. What I mean is that it has to be within, I mean like when in the part, I mean like in the part or in the space after using namespace. So this is the place where I define the variable. The definition is very easy and typically the same as the local variable, and it has to be like, for example, int number. Okay, so if I keep quiet like this, if I just quit, I mean like quit off and end the statement with a semicolon, this means that, and that's why I'm explaining here, we need to initialize it. We need to give it an initialization in order to identify it here. We need to, because this one is not initialized, we need to say that it's equal to 0, equal to 10, equal to 8, so that can be executed. But if we define the global variable here like this, so whenever we are reading it and see that, let's just let me just have this now see out number, and this is it. Okay, so let me execute that, and you can see 0. How 0 is coming? Where is it coming from? It is because automatically has been defined. Okay, so take this as a rule. So whenever we talk about like variables that hold a numerical values to be either int or a small short int or whatever kind of numerical value, or even double float, long float, so it should return 0. But if it is like as a char, for example, and we are actually executing this, it should actually return null, because this depends actually on the compiler. Some other compilers may need to return null, okay, as in response to that. Okay, so you can actually put it like this. But this is like an advanced kind of topic. Let's just ignore that, even it causes an error, so because it needs some configurations. Anyway, so the point here explains that the global variables, of course, they are automatically being initialized in opposite to the local variables. So numerical will take 0, or null will take as a character, as a string or char. Okay, so here global variables, why do we need to use them sparingly? Meaning that why do we need to carefully use them, or like purposely need to use them? These are the reasons. So they are not actually really important up to, into your level, let's say, but because you are learning them and you are learning this course for your best practice later on, so you can just take care of them. But for your fundamental learning and your basic learning, this is not really kind of important, but you need to take care of it later on when you are actually in a business environment. It's because programs are difficult to debug, and I'm sure that you don't know what do we mean by debugging, and like for your level of learning. But anyway, you just can't consider it like this. Debugging, it's just about checking the errors, the logical errors in the program, not the syntax error. Logical errors meaning that is the flow of the program running well? Is the program is exiting as expected or not? Is the program giving the output as expecting or not? That's it. So cannot be easily reused if the functions that cannot be with the function to make kind of function that cannot easily be reused in other programs, meaning that a function that can actually be difficult to be reused. And of course, I'm sure that because that's why this will make kind of complicated programs, and you're not reaching up to that level to think of that. Programs that are not hard to understand. Well, so this is an implementation of the variable, of the global variables. So you can just put it, let me just follow the same example here. So here, when you're printing this out, so of course it should print, let's see, because I'm defining this as an int. So this one is, we call this as a global variable. Sorry, I forgot to indicate it by the comment. And let me just come back here again. You can actually also, so in order to indicate this, you can from the main function number is, for example, num, and end line, and here. So let me just copy paste this again, because I want to show you that this global variable can be used in more than one place. Here you can see that. So alright, so whenever we call this, we do not want to receive any name here. We just want to call this kind of variable. So alright, so it's been written here already. So all we need to do here is just to call it, and that's it. So okay, so here imagine that number equal to, see what I'm doing here is that I'm updating the number. Int x, for example, let me just do some logic here. Int x equal to 4, 3, for example. Num equal to number, number equal to number plus, or like multiply by 3, or x, because I'm using x actually here. Okay, and I want to print the value of number. Okay, so this of course will indicate that I have another a different value here. Let me just return this and see. Okay, what might be wrong here? It has to have, yeah, process executed 0. Okay, should be, everything should be fine. Oh, that's the point. See, I cannot actually use, this is the call and this is the wrong, you see. This is the function call. It's not a prototype, so we cannot actually use the function call. We cannot insert, we cannot actually write the return type in the function call. See, that's why, see, I cannot have the, I mean like the output here. Alright, so if I executed that again here, see, this is the different, meaning that I can update the variable here. This is opposing to the local variable just now. If you remember, you cannot actually use the local variable, meaning like you cannot use that kind of variable, for example here x, to be used in for example here x equal to number plus 5, for example here, and you want to print this out. So this one will cause an error here. It shows you that this is not actually identified. However, you assume that it's identified in here, or it is defined in here. Okay, so this is actually the, I mean like the way how we use the global variable here. Well, a global variable can be typically, I mean like the way that we use it, it is typically the same as the local variable. You can put it in an if condition, you can put it in any kind of loop. Okay, you can do whatever, I mean the logic that requires it to, I mean like that requires to do with it. It's just that the difference between the global and the local is that the way that the variable that can be accessed in here. That's why whenever you want to have one variable that can be updated over different functions, this is the best choice for you to have kind of a global variable. Okay, when, I mean like, because finally, you see, because finally here it depends. No, so now if you're just, maybe some of you is wondering, so is this variable has multiple memory locations here? So this is, I mean like the answer here is no. The answer here is actually the variable value is being updated as long as the, I mean like as the sequence of the program is happening. Let me just have another function called again void and test. Let's just make it as test here in order to show you the, so now number equal to 3, okay, or like number equal to 10, for example, and see out let me just call this test 1, this is test 2, and from test 1, and I want to show this again from test 2. From test 2, this is what I'm trying to show in here. Oh yeah, test1, that should be test1 of course, and also here I need to call it once again. So num cout again from the main. I'm trying to play around with the code actually to show you the different aspects of how can we, like how can this global variable be manipulated. So number, end line, and here test2. This is supposed to be test2. Okay, so I hope this has no errors. Test1. Yeah, I need to include test2 also. Don't forget this. I need to include this as prototype. Why? It is because we have called the variable, we have called the function before its definition. And I think from now on you have to be very aware of this, meaning that whenever you are creating any kind of function, you will need to add the prototype of the function of it, whether you are typing it before the call or even after it. It's much better. It is the best practice for you to to go with. Well, so again, let me just call this function test2. Yeah, test1 here, test2. See, just small errors can actually cause that code. From the results here, you can notice that the importance and the impact of the global variable to say. So as you can read here from the main function, number is 8. It's because actually we didn't alter number in the first place. So the compiler comes here and reads the first statement here that it's a cout. So and displays typically the exact value of the global variable. And then so we called another function. This is the function, the first function that it's being called. So the function here, it's actually altering the value and displaying from test1 function is 24. It is because we have identified that. So now here in the first place, so that variable is storing a number. Whenever it has been defined, it is storing actually a value. So this value remains the same. We only displayed it. Okay, so when it comes in the test1 here, the value has been updated here. So now this value has been updated to this variable name. So meaning that, so whatever the number value, that it's 8 multiplied by 3. So now 24 is being updated to the memory of that variable. So now the value of number here is 24. So now if you want to see also again from the main, if you come back again to the main here, so if you're displaying now number, so number will be 24. Why? It's because the last execution has updated the value here to be 24. And you need to notice this. This is actually a very interesting example, and I used to be bringing this kind of example as an assessment type, because this will identify the best way how the student is able to understand the different updates to the global variable with respect to the information that he has learned about the local variable. So now again from the main, and this is the most important statement that indicates that the variable is being cooperatively, or it's being distributively updated over the different places of the code, or the different places of the program. Now going to the other function, that it's test2. So it goes into test2, number is equal to 10. So again, so 24 has been updated finally, and 10 is the final result that will be stored in number. All right, so so you can see that this is actually more than this example. Just look at this example and you can just try to bring it into the compiler and see that this example is indicating the typically the simple example. This is a global variable. This is a global variable, and how can we read from the global variable from different functions in here? We can update it here to 50, and you can actually read it as it is in the main function. Okay, well, so global constant. A global constant here is a named constant that actually can be used in everywhere in the function. So as we have a global variable, we have a global constant. And you remember that time when we were talking about the variables also, we also talked about the constant themselves. Let me just bring this code here. All right, so constant is being typed. You remember this const int. So now we are creating a constant integer, and that should be x equal to, or like pi. No, not pi. Actually, should be double. So pi, for example, I'm trying to bring realistic example 3.14. Okay, so this is the pi for the circle to calculate, for example, a circle area. Okay, so here we can bring this kind of variable as a pi, maybe like for example const interest rate equal to, for example, 0.34, like this. So we call these as constant, meaning you need to flip the notes back. You need to go and review the previous notes that you have studied in the chapter 2. You can understand what does it mean by constant. It's a variable that actually cannot be changed. Its value cannot be changed. So we cannot actually say constant. We cannot actually say now pi, for example, equal to 6.7. Okay, this is wrong. Why? It's because it has been defined as a constant variable. Same thing goes for the global variable. So because these are local variables, assume that these are local variables if they happen to be located within the function. Let's just handle the main function because this is the default way of the compiler execution. Okay, so these are local constants, local constant variables. All right, we can do the same thing if you just copy that. For example, if you want to bring this to be global, since as long as we same as we have a global variable, we can have a global constant, and it's just simply like this. So what is the difference between here and here? For example, let's just delete that, okay, because we want to make it kind of unique. Okay, so pi here, it can be also accessed from different locations. So I can say from here, instead of number, I want to say pi. Okay, and see, this is what I'm going to face here. Let me just run this and challenge the code. See, it was expected constant. Okay, let's just maybe there is something const. Okay, yeah, const double pi. Okay, fine. So that actually the wrong here, it needs actually a double, the data type, const data type. Okay, so if this is to be calculated in here, see, the function of test1 is pi. So it reads here, I don't want to confuse you, so let's just let me just go and hold. Let me just go and hold this, meaning commenting this to say, okay, also comment this code, and also comment this. I want only the value, I want the test1 to be only the only code that to be executed from the main function, nothing else. Well, so coming to the to the pi here, can I say pi equal to pi multiplied by x, and I want to print pi. I'm trying to discover something with you, and you'll see that, yeah, as expected and as I was expecting. You see, I have done this correctly without no errors when I was talking about the number, int number, okay? Even if I have double number, okay, doesn't matter. But what I'm trying to show here in this point, I'm trying to reveal that it's because this pi as a constant variable has been defined as a constant global variable, so I cannot actually update its value like this. You see, so that's why here, if I want, I can only, like, the only way to, I mean, like, to use it, it is just to print it out as it is. So let's just assume that this is not existed, and now we are actually reading, so it doesn't show any error, and actually it prints it out. So I can print it from here. I can also print it, let's say now I want to print it from the main function pi, and of course it should give the same results because this is a constant. I cannot actually update it. I cannot actually make any kind of updating or modifications on it, so it will show the same result from different functions. Okay, so that's why the purpose of pi here, for example, you want the function, or like you want this variable to be used in more than one place. They are not commonly used as popular as the global variable. Actually, in general, to say, those kind of constant variables, they are actually used for a specific purpose. But majority of the variables, when we talk about programming and you are building any kind of program, of course, most likely you're using, you tend to use that like the normal or like the ordinary variables more than the constant variables. But when they happen, like when it happens that you're using constant variables, this is the way how we use it. So global, it's typically the same as the local in terms of definition and initialization, and it has to be, when we talk about constant variable, it has to be initialized. We cannot actually type it like this. And if you remember, I have also explained this in the first chapter. I mean, like in chapter 2, when I was explaining about a local constant variable. Okay, when I was explaining about this. All right, so if I just executed the code here, see, of course there is an error because the error here says that it's an uninitialized constant. It has to have a value. So even if it is 0, it is considered a value here. You see? Well, so I hope this has been informative for you. I'm trying to bring a lot of practical parts here, so even in the lab later on, I think you will not have any error. I mean, like any issues or like any difficulties. Those who are with me in the lab. Well, so a global variable. Let's just read some of the concept. Let's read some of the theory. However, I like actually to explain by example because this will train your understanding rather than your memorization. So now coming back to coming back to the part that you need to memorize somehow. Well, so a global variable is a named constant that can be used by every function in the program. Okay, as we have shown here. So you can actually apply, like you can access it from any kind of function. You can either use it in the main and any kind of other functions, like here in test 1, for example. It is useful if you have unchanging values. It's actually, this one, this statement is repeating the same definition of the constant variable of the local variables that we have discussed in chapter 2. So I believe you are not actually, you should be kind of familiar if you're up to date in reviewing your notes and your study notes. They are safer to use than the global variable, since the constant variable cannot be modified during the program execution. Okay, so here, that's why you need to, to take note of this, you need to be aware of this. So whenever you are defining a global variable and you have normal variable, and you forgot that you have defined that variable, and now you just coincidentally, you are defining a variable of the same name here, or like you are using the variable of the same name here, number. So it seems that this means that you are actually updating that variable that you have defined as a global variable. Even if you don't meant to do that here in that particular function, and later on you want really to use that variable, the global variable, in a real way in this function, where this is the function that you are actually intending to use that variable, then that will bring an error if you're trying, for example, to read the value of number here. So you think that number is still 8, but somewhere it has been updated. And if you're actually using it, so what's going on here? So number has been set to another value that is 56, for example, here. It's just indicating that this is it should be actual number, to correct you, in order not to confuse you with that. Okay, so you see, so number is constantly has to be 56, and this is the point. That's why actually this slide, or like this statement here, says that it's more safer, because that they cannot be updated. The user will, I mean, like the programmer will have no choice to update this value in the same way as what happened here. Okay, as long as we are dealing with constant. But with a double, I mean, like with the global variables, the normal global variable, that actually it's a very kind of suspective to have a changes like this. So you need to be careful whenever you're dealing with a global variables, especially when you have like a long program that has a lot of functions that are to be connected to each other and deal with a variable that are to be transferred, that have their values to be transferred from one place to another. Well, so local variables can have the same name as a global variable. So that's actually possible, meaning because you see here, I'm just trying to mention to you. So let's say that I have number as a global variable, and I want here to initiate like another int. Here I'm using another variable called number. This doesn't mean that I'm replicating this. I'm not using this variable, but actually I'm using a new variable with another value. And now I want to print out, okay, so number here. However, this is not recommended at all, because actually it will duplicate the both values in here. So that's why you should be actually like trying to differentiate between these two. You see here, why is this happening? Who can say? I mean, like you can think of it. I will not actually I mean, like tell you right away in this. You just pause the video and think of why is this happening. However, you're actually initiating a new variable with the number equal to 2. This is the kind of tricky question actually. But if you think of it like the way how the compiler is acting, you will find the answer. Why is it 8 instead of 2? However, we are reading from the main. Pause the video and just think of the question. Well, so let me just tell you the answer. I was trying to be silent just to give you some point. I mean, like some point where you need to pause the video. Well, so like the answer here, it's just the way. Okay, fine. Since we are starting from the main, this is fine. But the compiler before the main, even it goes to some code. It actually passes through some code, and this is the code that is being passed in the first place. Okay, so that's why main here, it's not the very first segment of code that to be passed, but it is regarding to our coding within the functions. Main is the main function that has its code to be executed. But when we talk about the other code, this is the code that will be executed even before the main function. All right, so that's why here int number equal to 8 happen to be registered in that memory, and then num equal to 2. Okay, and here, so when we access the main function, so now number is already 8. So this is not an update since this is a new variable here. So these two variables are actually different variables. I mean, like when you go into the memory, you will not actually be returning. I mean, like you will not find in the memory that these are like of the same location. This will be in another location than this one. However, they are having the same name. So whenever you're executing this, so now number, it's because the main, I mean, like the global variable, it's the most dominant variable. It's more dominant than the local variable. So that's why any cout to the global variable that has a name, the same name of the local variable, it will print the value of the global variable. And that's why I'm telling you this is not really recommended to follow. However, it doesn't have any error as you can see here. I don't have any kind of error with that. But of course, it's not recommended because now you want to show the value of number, which is the local one. You are not able to show it. It's because this one is being overtaking the value. So whenever any execution to the value of number, so the compiler will keep referring to the dominant variable that it's actually the global variable. All right. So that's why actually it's used with the same name. So when function contains local variable that has the same name, the global variable is unavailable from within the function. So the local definition hides or shows the global variable. Well, so look at this. For example, here So this example actually says that there is a global variable, and then from the main, so it's actually calling another function. So this is the function. The function actually updates that global variable here. So constant. So this is actually a constant variable. You see. So constant function equal to 1000. So now the display here is 1000. And maybe I didn't explain this here, but I explained it in the previous chapter, in the last, I mean, like in the chapter 2. The same way you need to deal with it. If you want, if you happen, I have told you just now that we cannot, if we are talking about the constant variables, we cannot change them. But the way to change them is to recreate them again. And this is actually called a recreation, meaning that we have redefined the constant variable right again. Okay, so it means that here we need to write the const keyword with the data type of the variable, and then the variable name with the value that we need to change over the basic value. So here, when you go and read, we didn't actually, I mean, like the compiler or the memory didn't destroy this, so this is still existed, but we have defined another variable that has the same name. Okay, so this is not possible, of course, with the, this is a local constant, this is a global constant. Okay, but this is not possible when we talk about the ordinary variable. Just now, for the example that I have shown to you just now, when we talk about the normal global variable and the normal local variable, of course you will not find this is the, I mean, like that this is the way. All right, so even if you are actually I mean, like, see out, if you are printing like in line here, yeah, I was reading this. See, so now it's actually 2. It's because actually number 8 now it's already yeah, actually I had actually a little bit of confusion in this. I will need to update you with that. I mean, I will need to repeat myself, or like update myself with this. I apologize once again. So let me just confirm you with this. So now when the code is actually being executed here, so first thing is that the compiler looks at that there is a variable here. It's a global variable, so it stores that variable name with its value, and then it goes into the main. There is another variable with the same name. So this is not same as this, but it's another variable that has the same name. Okay, a local variable here. So whenever we are copying this here, so we are actually using, I mean, like updating, not kind of updating. It's actually we are starting like a new variable, but local variable, but with the different name. That's why whenever you are actually I mean, like displaying the code, I mean, like executing the code, you, of course, you will have the value of 2. You cannot display the value of I mean, like the number here. But if you go here, for example, in test 1, and you want to display the value of number, and you can see this from here. So value of number is already, from test 1, is already 8, as you are seeing here. Okay, so what I want to confirm you again is that, so the local variable, it's isolated from the global variable. So when you have a global variable here, it has been defined. Okay, so the answer here, it is 2, is that the compiler will look at the last name of the variable and fetch it out. That's why we have 2 here. That's why my question was, when I ask you to pause the video and think of why we have, I mean, like, what do you think the answer should be here? The answer here should be 2. Why? It's because the compiler have defined the global variable in the first place, and then it comes to the main value, to the main function, and then define, and then actually reaches to that line of code where actually a new local variable is being defined with the same name. So the compiler now fetching the local variable, since actually it is actually more like nearer to the, I mean, like to the compilation, to say. But here, when you are reading from this, we do not have any kind of variable that it's actually updating that. So that's why that updating that global variable, or like taking the same name as a global variable. So that's why you here you can see that we still have 8. Well, so let me just go with this. So this is actually, with that, this is the last part, or like this is the last slide that we have for our discussion in this session. And I really hope that you understood whatever information that has been exposed to you. Of course, let me just, since I have flipped the slide in here, I want to tell you that from here, from this point to that, I mean, like to the next, I mean, like to the rest of the slides until the end. Of course, this is actually out of our scope. It is not mentioned in the TA plan, so we will not be covering it. Well, so with that, I would like to thank you for, I mean, like for watching, and I really hope you, if you have any kind of consultation, if you have any kind of question, please don't hesitate to refer back to me and contact me. So with that, thank you so much, and see you in another recording.